But yeah, so I want to go through the voting machine CTF from Quill. And the link's in the chat, but taking a quick look at it, the overall description here is that there's a protocol called vToken, which is a governance token that allows holders of that token to vote on proposals for the community. And the goal of this hacker is to get 3,000 votes in order to have a malicious proposal accepted for them. In the overall outline of the objective, we want to be accumulating at least 3,000 votes. It tells us that through a phishing attack, we were able to get the private keys of 3 users, Alice, Bob, and Carl. Alice has 1,000 V tokens. Bob and Carl don't have any. And so they have that set up in Foundry. And we have access to all three of those accounts. So we're going to try and do try and hack this contract with those 1,000 tokens to give ourselves hopefully 3,000 votes. So switching my screen over to VS Code, we can run down and take a look how we can do this. So this is the voting machine contract. If we take a quick look at the attack test, this is the Foundry test provided by the CTF. They do a couple basic things. They set up accounts for Alice, Bob, and Carl with some basic addresses seeded with numbers. They set the vote token contract to be called vToken. In the setup, they start the prank as owner. They deploy vote token, and then they mint Alice 1,000 of those vote tokens, as they kind of mentioned in the overview. And then they tell us to implement the solution here. What they're checking for at the end is that the votes that are grabbed from this get votes function is at least 3,000 or is exactly 3,000. And then the last piece is that the balance of the hacker, even though they didn't specify this in the description, they want the balance of the hacker to be 1,000. So that's what we're looking for. So taking a look, running down the voting machine contract itself. So vote token is an ERC20. So we've seen a lot of these, pretty standard. They have at the top a single storage variable owner, a simple only owner modifier, and the constructor sets the owner equal to the message.sender. That all seems pretty standard. Mint, so here they're modifying the ERC20 mint function. They mint first, and then they call this function move delegates. And so this is likely trying to link together the tokens and the votes associated with that. We'll take a look at move delegates, but if I had to guess, address 0 and then 2, what they're doing is, in addition to minting tokens, they're using move delegates to mint voting power to the address that they're minting the tokens to in the same amount. So essentially, when tokens are created, the same number of votes are created via delegation. Burn, they're just doing the same thing in the opposite direction. They're essentially burning votes by sending them from that individual burning it, or I guess the owner can burn delegates for anyone, so they could burn people's tokens if they wanted to, and then sending those delegates to the 0 address, effectively burning them. Here we have a mapping, which this should be declared at the top of the file if they're following correct format. But here we see that they have an address to address mapping to indicate delegates. So yeah, that's interesting. We'll see exactly how that's being used. Checkpoint from block and votes. Not exactly sure what this struct is doing, but we'll take a look. Here's the move delegates function. it's taking a from address and a to address and an amount. It's checking if from is equal to, which they disallow. If you call those with the same address, this function, it won't throw an error, it just won't do anything. And then it looks like the first if statement is updating the from delegation, and the second if statement is updating the to delegation. What's it doing? So at the top, it's checking the number of checkpoints. Okay, so there's more storage variables down here that they didn't put in the correct location, but we do have a storage variable that says the number of checkpoints associated with an address. So that gives us some more context. And then a double mapping that takes an address and also a number and returns the checkpoint struct, which is from block and votes. So likely they're using this checkpoint basically saying at this point in time, this many votes were associated with that address. So that's likely how they're using this. So under that understanding, let's say from num equals num checkpoints. So they're getting the number of checkpoints from old. So they're saying if the number of checkpoints is greater than 0, then set the checkpoints double mapping of from and from -1 dot votes, set that equal to from old, or from old is being set equal to the number of votes in the previous checkpoint. And then from new is just saying from old minus amount. So this person from, they're delegating votes away from themselves, so that makes sense. Take the number of votes they had at the last checkpoint and subtract the current amount that you're trying to transfer, and then write a new checkpoint. And then similarly, in the other direction, on the to side, it is checking if the person receiving votes has had a checkpoint before. If yes, then take their previous checkpoint number of votes and add the amount that they're receiving. Otherwise, it's just 0 plus that amount. And then they'll write checkpoint. So move delegates is effectively transferring delegates from, or votes from, one individual to another, and they're using the system of checkpoints to say, basically at this snapshot point in time, this is how many votes that individual had. And so you could look at those checkpoints over time to see how votes are changing. Looking at how delegation occurs, so they have this function where you can check delegates. So let's see, delegates of address, which returns another address, basically who are you delegating to? And then this one is delegate with, delegate without the S is basically providing your votes to somebody else. If I had to guess, that would be the assumption. We'll have to look at how the internal delegate function is implemented. Get votes. So we know that this is the function that's used in the test to see if we've done this successfully. So what does it do? It takes an address and it looks at the number of checkpoints that address has to get the latest checkpoint. And then it says, if those checkpoints are greater than 0, return the number of votes in the last checkpoint. And there's -1 here because it's indexed on 0. So if there's 5 checkpoints, the 5th checkpoint exists at index 4. Otherwise, return 0. So this is just using these checkpoints. And so the number of votes and checkpoints is how we'll be able to determine if a delegate has enough votes. So that means that ideally, we're looking for a way to increment the number of votes in the most recent checkpoint to be equal to 3,000 for the hacker. So we have to find a way to do that. Then we have this internal function delegate, which is used in the external delegate function. It takes the address of the person calling delegate and the address of the person they're delegating their votes to. So current delegate, it checks if they've already delegated to somebody else. Then it grabs the balance of the person that's delegating to see how many votes they should have associated with their token. Then it updates the delegate mapping to be equal to the new individual. And then it uses move delegate to transfer from the old delegate to the new one. So if I delegated to somebody else, to person A, but then later decided to delegate to person B, person A would lose those votes when I call delegate to this new individual. So we know that we can't just repeatedly call delegate because it's going to attempt to move those, or it seems that it's properly accounting for updating who the delegate is. Then write checkpoint. So this is how it's updating the number of votes in the checkpoints. This is a pretty critical piece of it. And it's taking the person who's receiving the delegation of votes, the number of checkpoints, the old votes they had, and the new votes they have. It's checking the block numbers. So checkpoint is that struct block is using block number as a store of history for point in time. And then it says if the number of checkpoints is greater than 0 and the checkpoints is equal to block number, that's interesting. Dot from block equals block number. This is just like a sanity check, I guess. Then checkpoints delegate, and then the most recent checkpoint should be equal to new votes. If the above isn't true, let's say that they have no previous checkpoints because they've never received delegation before, then they create a new checkpoint object and then add that checkpoint object to the checkpoint mapping. So what's interesting here is that it seems that move delegates, which is called within delegate, and the mint function is properly accounting for transferring the delegate, right? If I delegate from one person to another and I'm still owning those tokens, but if I transfer my tokens to somebody else, it's not linking the votes that I have already delegated to the transfer of those funds. And so this is something, again, we've seen this in the past. I think we saw this last week, where some logic is implemented on top of an ERC20, but then the underlying ERC20 functions are functionally forgotten about. So the underlying ERC20 function here that I'm thinking of is transfer, right? So they didn't overwrite transfer within this contract. So the transfer function it simply can't be accounting for the fact that delegates or votes need to also be updated to move with those funds. So essentially, if I were to think about how you patch that, you should have a super transfer function that's overriding the underlying ERC20 transfer function, which would basically say the number of funds that are being transferred, that delegation and those votes associated with that need to be moved from whoever they're currently delegated to the individual that's receiving the tokens. But this doesn't do that. So I think that this is probably pretty straightforward. I think really all you have to do here is basically, Alice delegates to hacker, then Alice transfers funds to, what's his name? Is it Bob? Transfers funds to Bob. Then just repeat. Bob delegates to hacker, Bob transfers to Carl. Then Carl delegates to hacker. My computer's acting awfully slow. And then Carl transfers to hacker so that the hacker ends up with the 1,000 at the end. So let's give this a crack. Say vtoken.delegate hacker. Then, oh, this needs to be capitalized. vtoken.transfer to Bob. And we need to change prank to Bob, because now we're working with Bob's private keys, which we got through the phishing attack. We'll do vtoken. I don't know what's slowing down my computer. Normally Copilot would help me out here. There we go. Do this in line with our comments. Transfer it to Carl. Then change prank to Carl. Delegate to hacker. And then transfer to hacker. So this should work. So essentially all we're doing is basically saying that the person who currently has tokens can delegate. When they transfer those functions, that delegation is not cleared, so the hacker still has the votes. And then the new individual can also do that delegation. So I'm going down to the console. Oh, let's see. Wrong argument function call. One argument given but expected to. Oh, I need to be giving the balance. Whoops. Yeah, we know it's 1,000 all around, so we'll just add that to all of these. Okay, so now in the console, do forge test. I don't know why my computer's being so slow. Move this up a bit so you can see the output. So as this is going, something to consider here is that the setup of the CTF basically says that you're able to capture the private keys of 3 individuals through kind of warning, but you're trying to use private keys of individuals that you secured through a phishing attack, which cool, all good. Okay, so we can see that this worked. So this implementation was pretty straightforward. Is there a question? I'm just going to throw you on mute, just because some background sound. Okay, so this passes, but yeah, like this also doesn't really require that you steal anybody's keys through a phishing attack, because I, as the hacker, if I wanted to, I could just, I could spin up a bunch of my own addresses and run this loop myself without needing to use anybody else's keys. I could just spin out a bunch of EOAs or contracts and then hack it that way. So yeah, let's actually, given that this was a little bit short, let's go ahead and let's quickly implement something to illustrate how you could do this without needing to have anyone else's keys at all, right? So let's say we're going to get rid of these guys. They're not needed anymore. And we're going to call mint to hacker. Let's just say that, the hacker purchases, for real, purchases the initial shares, right? And let's say he purchases, 500. We'll just change it up, right? And then we'll start the prank as the hacker, because that's the keys we have. The hacker has some balance, right? No, I didn't delete hacker. I don't know why it's telling me that. That's weird. Seems like my system's having some issues, but we mint to the hacker starts the prank. And so then I'm going to, let's create a smart contract that can do this for us, just to show some methodology here. So new file, attack.sol. Need to do all the basics. Throw in our identifier, make it unlicensed. Pragma, thank you, Copilot. My system's speeding up a little bit. And then let's say we need to import vote token from vote-token.sol. But I guess it's called voting machine. The name of the file is different than the name of the contract. Okay. And then in our attack, basically we'll create a contract. Let's say attack. We'll implement some basics like creating an owner, because we don't want somebody to hack our hacking contract. Whenever you do something like this, you need to allocate space for the contract that you're trying to target. So in this case, we have a target address that's mapping to the vote token contract type. And then what we'll do is we'll spin out a bunch of contracts. We'll create contracts, as many contracts as we need to hack this thing. So we'll create another contract above this that says just contract account. We'll throw that there. We'll fill that out later once we know the logic. But here what we want is let's create a mapping of contract accounts that we can use to exploit this by transferring funds amongst themselves. Whoops. Oh, don't do that. Go there. Don't say it. All right. So we'll use these storage variables to support our attack. We'll do a constructor. This is actually almost exactly what I want, but I'm going to make this an address instead. So in the constructor, what we're going to do is we're going to pass in, we're going to set ourselves as the owner, and then we're going to say that the target up here is the vote token target, so that we can pass that in. And then we'll just add a little modifier here, only owner. Again, protect our hacking contracts so that only we can call these things. And then let's write the exploit. So function exploit. We already passed information in the constructor, so we don't need to do it here. We'll make it public and only owner. This is incorrect from Copilot. That'd be a hack for sure, but we can't do that. So first what we need to do is we need to understand how many times do we need to loop through this process of delegating and transferring tokens in order to get enough votes. So we know the threshold we're trying to cross is 3,000. So let's give ourselves a little breathing room. We'll say 3,010 divided by target. Target is the vote token contract dot balance of this address. So this contract will fund it with funds from the hacker contract, and then depending on that, we'll know how many loops we need to iterate through. Based off of that, let's say create required number of contracts. We know how many loops there are, so we know how many contracts we need to create. So it's way ahead of me. Let's make sure that this is right. We're going to say uint I loops increment. we can simplify this by just saying accounts.push new contract account and dropping that here. So that will create new smart contracts of the type contract account up here. So now we have a bunch of different addresses that we can use to hack this thing. And so what we would do is we need to transfer tokens to the first contract we created. And so we're going to say target.transfer. It's all over it. Address accounts, we don't have this much money, so that's wrong. From Copilot, we're going to do target. Yeah, now Copilot has it. Target balance of address this. So we're going to transfer all the funds that were funded into our hacker, our attack contract, and transfer it to the first new account that we just created. So now that first account can now delegate to the hacker and start building up our delegation. And this again is using all of our own funds. So then let's say exploit via looping delegate plus transfer. Okay, so it's almost got it. It's got the right idea, but it's not quite it, so we'll write it out. So uint I less than accounts.length, and then increment I. And then, okay, so here, now we need to write the logic of the contract account. So contract account, similarly, we need to do some simple things. So yeah, we need to say first, let's protect our contract accounts. This is just good practice. Owner, address, we want the hacker. This is who we're going to be delegating to from these accounts. And then, yes, we also want the contract that we're calling. In the constructor, let's set these variables. And we'll say we're going to pass in the hacker address that we want to delegate to and the address of the token contract we're targeting. Owner, as normal, message.sender. So these will be owned by our attack contract. Hacker will be set to hacker. And then target is set to vote token, exact same way as we did it in the attack contract. Yeah, sure, we'll add that modifier. Thanks, Copilot. Then there's two functions that we want here. We want to be able to delegate. So let's say function call delegate. Should be only owner, should be able to do this, public. And then simply just target.delegate and then delegate to the hacker. Then we also need the ability to transfer. So again, Copilot is close but not quite accurate. Transfer address to, and then uint 256 amount. Only this is public, only owner. Let's see. Got my modifiers a little mixed up, but it won't matter. They'll still execute. Should be capitalized. Target.transfer to and amount. And what we'll do is we'll transfer it to the next account in the sequence. So what did we just do? We defined a contract account. These contract accounts are programmatically deployed by our attack contract in this function here. This is throwing an error because we just added a constructor. So the constructor wants to take the hacker and target variables. Hacker in this case is the owner of the attack contract. And then it wants the target. So it looks like Copilot's got it, address of target. So now all these new accounts will be set up with the proper inputs and it has the functionality to call the token contract we're trying to exploit. So now in our loop, we can implement some logic. So what do we want to do? The first account already has funds, so we want it to call delegate, Copilot's all over it. And then once it's called delegate, that account should transfer those funds to the next account. So we're going to do accounts plus one. And then one thing we want to be aware of here is that, okay, the Copilot also has one. We're not transferring one. We're going to do target.balance of, and then we'll do the balance of address accounts I. So we're transferring the balance, the entire balance from the previous account that we created to the next account that we created. I don't think we need this address here. Maybe we can just do accounts. No, we do need address. We need to cast it because balance of wants the address. Okay. And accounts is returning the type contract account, not an address. So that's why we're casting these to address. All right, but so now at the end of this loop, the logic is slightly different. So once this is equal to, we're now on the last contract account that was created, we want to call delegate, but then there's no account after it in the mapping. So we need to modify this logic so that it can account for the fact that the last account should be transferring to the hacker instead of transferring to the next index in the accounts array. So what we'll say is if I does not equal accounts dot length minus one, right? So again, like indexing on 0, accounts dot length minus 1 will index us at the last account in the array. We're gonna remove that. We're gonna paste it in, add a tab to clean it up. And so now what this will do is for all except the last account, it will transfer to the next account. But then for the last account, it won't transfer it anywhere. So we'll just add a line afterwards and just say target.transfer address accounts to call transfer. And then we're going to do, okay, actually, got ahead of myself there. So what we want to do is grab accounts to, and then do call transfer. And we'll transfer it to the owner, which is the hacker in this case. And then what we'll transfer is the entire balance of this account, which is the second account. It's the last one in the mapping. And let's see, I think we need, nope, we don't need one more, we just need a colon. What doesn't it like? Tell me. Call transfer is not visible. This should be accounts to, why doesn't it like it? Looks fine to me. Strange. Call transfer. Oh, well, I have address too here, and this should be address account.
Should be account two.
Yeah.
And wrap by address.
Yeah.
And I think the first problem is the 2 is not a defined number
Of
because of the top is uh
contract account
yeah
accounts. Sorry, go ahead.
because it is a dynamic array and
Yeah, I should be able to access a member of. It's telling me that I can't find call transfer in the contract account contract type. But we have it here. I mean, we're doing essentially the
oh
same thing.
some typo I think
Oh yeah.
looks like typo. Yeah, call transfer is not.
Oh, jeez. Thank
Yeah.
you. Good catch. There's something was strange there. Okay. Call transfer. Good catch. Okay. It's always something dumb like that. Sorry about the background noise. There's a little bit of construction going on near me. Okay, so now this generally should work. We'll let's give it a crack in the actual test and see where we need to clean it up. It's probably not perfect right now, but what we'll do is we'll say we have the hacker now, and we'll say, oh, we need to import all of this. So import source attack.sol, and then down here we'll say attack equals, oh yeah, there we go, attack equals new attack, and attack.exploit, and then let's see what happens. Oh, geez, sorry for the background noise. Okay. So it seems like the issue here is that I forgot to transfer funds to the attack contract. So what we need to do here is say v token dot transfer address attack 500, which is what we funded it with. Now let's give this another crack. All right, so assertion failed. Let's see. I'm not sure exactly why. I'm gonna have to run this. Should have run this way. That's last time, but taking a quick look back at the code, see what's up. let's take a look at our output here and see what's going on. So let's see. It looks like it's mostly working. So we see that we're transferring to the attack contract a value of 500. That looks good. Then the balance of is 500, and then based off of that, it says, okay, we need to create 1, 2, 3, 4, 5, 6 accounts, which is correct. And then you got to remember too, like dividing and solidity, it rounds down, so that could cause issues, right? If we are rounding, it could round too low, so sometimes you need to add a larger value or something like that. But then, so we know the first contract is 816. So vote token transfer to 816. That's right. We're transferring the funds from the attack contract to the first account we created. That seems good. Delegate, it's delegating those votes to the attacker, and then it's transferring that balance. And then, let's see, what happened here? Balance of transfer, yeah, that looks fine. Transfers it. Then this next contract account is also calling delegate. So the issue,
Because looks like final assertion is 1000,
yeah,
but you transfer 500, right?
right. So it's not transferring it to the right place. Let's take a look. Transfer to owner. Owner should be the hacker. Yeah, you're right. It's because, yeah, we just didn't we only had 500 tokens, and we didn't update the tests that they created in the CTF. So now if we run it, we should see it is successful. Even though the number is different, we're not transferring it to the right place. So, and you might have called that out already, but I missed it. So, balance it's telling me 0. Transfer contract account to value 0. Yeah, so it's somewhere this value is getting lost. Let's see, it's probably
Looks like not the accounts, and the input looks not should be true. Like maybe it's accounts balance should be correct.
Yep, good call. I was doing it off the assumption we only had to do this 3 times from the original CTF, but you're right, we dropped it down. So there's 6 accounts. So accounts.length
Yeah,
-1, right? That should be calling the correct account. transfer it. Okay. Is it not accounts.length minus one? It should be. Let's see what's happening this time. So we know the last account that's created is 355, and this last transfer is calling from 355. So it seems that 355 never got the funds transferred to it. Contract 2355, value of 500, so that did happen. Oh, it's because I didn't update it here. I'm transferring a value of the incorrect account. So I think we basically have the right solution. I just, there's a couple things I hard coded that I shouldn't have. All right. That seemed to work. So that's basically a way that you could do it without doing what the CTF says of like doing a phishing attack. You could just create your own accounts and move through it. So a couple different things to remember here. Maybe there's a scenario where this system is gated and you can't just buy the tokens, and so that's kind of how the CTF was set up. And then you're grabbing private keys to kind of do this type of attack. But something to remember, right, is that like anybody can spin up as many accounts as they want. And anytime that you're building something on top of a ERC20 contract, when you consider how you're accounting for your mechanisms, you have to remember that this contract comes with a whole suite of underlying functionality, and oftentimes things like transfer, being able to transfer from and to the contract directly without necessarily calling these other methods. That can cause problems if you aren't like accounting for that in the correct way. So seen that a couple times, but you should always be asking yourself when you're looking at a contract or if you're developing a contract, what happens if funds are sent directly to or from this contract using underlying methods, or just by transferring funds to the contract? Can that mess with the internal accounting of the system? Yeah, so that's kind of the hack for today. It looks like maybe you guys lost my screen at some point, but let's see, I'll pull it up again real quick so that you can see that we do have this passing. Any questions? I know I got a lot of background noise. Sorry about the drilling, but yeah, that's kind of the hack for today.
So can I ask? So the good practice of this problem is maybe the vote token contract uh should be add a update function in after transfer. Then should be remove the delegate power, right?
Yeah, exactly. So what needs to happen here is that when tokens are transferred, the delegated votes also need to be accounted for. And so right now they're not doing that. But if we look, let's take a look. ERC20. We'll find transfer. Right. So this is virtual, right? So we could go into voting machine and say function transfer, right? Take the same members, so address to and value. Address to, value. And then in here, you know, it should be basically saying, you know, this is the last step, is the interaction, right, of transferring. Oh, what happened here? That's really weird. Transfer. I have more typos in here. Can't spell transfer. And then it's going to tell me to override. Essentially what you would do is you would go in, address to, UN256 value, and you would add the logic here so that it's essentially saying move delegates, and then you would implement move delegates there. Right, I once going to say returns bool. So let's say returns bool. And for now, just so that doesn't yell at us, we'll just say return. So yeah, basically what you would do is, this isn't fully implemented, but you would say whenever somebody transfers a token, make sure that their delegation is also being appropriately moved. And so this contract is actually pretty simple, where you can only delegate all of your tokens. You can't delegate a sub portion of your tokens. And so you would just call move delegate, and then all of a sudden you're in a situation where you don't have a problem, because there will only ever be as many votes as there are tokens in the system. And so this way, this would be secure, right? Move delegates needs to be implemented, but you know, you get the sense of how that should work. Does that answer your question?
Yeah, I see. Thanks.
Okay, great. Well, I think we'll end it there, since I got all this construction going on. But thanks, guys, for joining. I'll throw this video online if anybody wants to go back through it, and for those folks who didn't make it. And I'll catch you guys next week. We do this every Friday, so look forward to seeing some of you guys then.